Okay, today we continue on with similarity, and we're going to be talking about shortcuts that we can use to solve for similarity problems. So when we look at our shortcuts up here, let me make this just a little bit bigger. Oh, maybe down to, maybe I could just spread it out like that. That'd be good. Okay, just like we had shortcuts when we were proving triangles are congruent, we also have shortcuts to prove that triangles are, especially triangles, are similar. So these shortcuts consist of just three. Remember when we were proving triangles were exactly congruent, we had five, but these are called the shortcuts for similarity. So we don't have to know everything if we know one of these three theorems is true. Okay, so we're going to go through these three shortcuts. The first one is called AA, and we just really make it short by calling it AA. And this postulate, says that if you have two triangles and two angles within one triangle are congruent to two angles in another triangle, well, then we know they're similar. And remember, similar does not mean they're exactly the same. It just means one's the smaller version of the other. So in this particular case, we know that angle K is congruent to angle Y, and we know that angle J is congruent to angle X. Therefore, we have triangle, the first one, JKL is similar, which is a little squiggly sign, to triangle, let's say, we've got to match these up carefully, XYZ. JKL goes with XYZ because we have two angles of one triangle congruent to two angles of another triangle. Now the second shortcut, I'll change colors here, is called SSS. So we just refer to it as side, side, side. Now obviously this triangle is not the same size as this one, but what it says is that if we have, for example, side AB, and that corresponds to side PQ, sorry. So if that fraction equals the fraction of AC over PR, and that fraction equals the ratio of BC over QR, if when I reduce all three of these fractions I get the same number, then I know by side, side, side the sides are proportionate. So they compare to each other by the same factor. So in this case, we have triangle ABC would be similar to triangle PQR. And our third shortcut looks at two sides and the angle between them, the included angle. Okay, so we've got an angle at X and an angle at M, and they are congruent to each other, I can tell by the markings. What I have to know is that the side XZ over the side MP would equal the same fraction as XY over MN. So if Z over MP will give me the same fraction as XY over MN, then I have two similar triangles. Okay, and that would be the included angle. If I'm looking at this side and that side, X is the included angle, and if I look at MP and MN, angle M is the included angle. And if those two fractions are the same, then I know triangle XYZ is similar to triangle MNP. Only three shortcuts, AA, SSS, and SAS. Okay, so let's look and see if we can, let's see if I can do this without, nope, I guess not. Better go here, and I'm going to zoom in. Let's go to 125% so we can see a little bit better. Of course, it's the same thing on your page. Now, I'm checking to see if the triangles are similar by AA. Do they have two angles the same? 90 and 60. Let's see, that adds to 150, so this angle over here is 30 degrees. Does that look like the same as this triangle? 90, 35, and this would have to be 55. So the answer is no. I do not have two angles congruent. Now let's check over here. 77 and 48. Let's see, that adds to 125, so this angle left over is 55. And 48 and 55, let's see, that's going to add to 103. So this angle is the leftovers, because I know the sum is 180 of 77. So do I have two angles of this triangle ABC that are the same, or the same measure as two angles in the other triangle DEF? And the answer is yes. So since they are, I can write a similarity statement. Triangle ABC is similar to triangle D, and I want to make sure I get this right, F, I believe, and E. Oops, I said that wrong. Let me get my eraser. Okay, I thought it was going to be fancy, and it wasn't too fancy. Okay, now let me grab my pen back. I'm green. Okay, A is the 77, so I want to start with D over here. B is the 48, so I want to say E over here, DEF. Okay, actually went in order. Okay, now C might be a little confusing to you, but once you remember that, of course, vertical angles are congruent anywhere, anytime. I do get one angle of the top triangle congruent to one angle of the bottom triangle. And then because I have a transversal between two parallel lines, I do know the angle at X is congruent to the angle at Z. Okay, it's also true that angle W is congruent to angle V, but I don't need three angles, I only need two. So by angle, I can say, yes, I do have two similar triangles. Let's label the top one as triangle, let's see, X, what's alpha order? WXY. WXY, I'll call it, is similar to triangle, and since I said W, I want to say V, and then I should say Z, and then Y. Okay, D, and this is another variety. We've got a triangle here that's overlaying the one WZY. Well, look at, they both have angle W. We have triangle WVX, and we have triangle WZY. So yes, they are similar by angle because they do share two angles. They have the two angles at W and then the right angles at V and Z. So I can say triangle WVX is similar to triangle, the big one, WZY. And remember, order matters when I'm naming these. Okay, we want to determine which two of the three triangles are similar. So I want to look at these closely, and I'm going to have to compare the sides because I don't have enough information on angles to say a whole lot. So I'm going to zoom in a little bit here. 125, I guess I already am zoomed in. Let me try again. Let's see. I want to make it a little bit bigger, so let's go to 150, mostly so I can see it. So let's call this triangle 1, triangle 2, and triangle 3. So first let's compare triangle 1 to triangle 2. I have to compare the sides. So 5 over 4, those look like they go together, equals 8 over 7. And does that equal 7 over 6? Okay, so what I did was I checked the small side over the small side, the largest side over the largest side, the medium over the medium. So when I cross multiply, 5 times 7 is 35. Does that equal 4 times 8, which is 32? Nope. So this is a no-go. 1 and 2 are not similar. Let's try 1 to 3. Okay, 5 over 2. Does that equal 8 over 3.5? And does that equal the 7 over the 3? Okay, 2 times 8 is 16. Does 16 equal 5 times 3.5? Let's see, that's going to give me 17.5. So this one, no. Now I think I'll try 1, or we should try 2 to 3. We haven't tried 2 to 3. I'll bring it up over here. So we're checking these two, 2 and 3. 4 is to 2. Okay, that's a 2 to 1 ratio. As 7 is to 3.5. As 6 is to 3. Let's see. 4 times 3.5, that's going to be 14. 2 times 7 is 14, so that one works. 7 times 3 is 21, and 3.5 times 6, 21. Check it on your calculator. So what we found is triangle 2 and 3. And let's see, their scale factor, again, just look at one of these fractions. Here's one that I know pretty well. And I know that this reduces to 2 over 1, as does this middle one. So the scale factor, sometimes referred to as the K factor, is a 2 to 1 ratio. This one has twice the lengths as this one. Okay, we're going to do the same thing here on another problem. Let's label our triangles 1, 2, and 3 so we can keep these straight. Let's try triangle 1 to triangle 2. 24 is to 18, as 16 is to 12, as 20 is to 16. When I compare the corresponding sides, we can reduce these fractions. 6 goes into both of these, and this becomes a 4 over 3. Let's see, 4 goes into both of those, so that becomes a 4 over 3. And 4 goes into both the top and bottom, and this becomes a 5 over 4. Okay, two fractions are the same, but the last one's not, so it's a no. It's not 1 and 2. Let's try a 1 to 3, see if that one works. 25 over 30, does that equal 16 over 20? And does that equal 20 over 25? Reducing 24 over 30, because they're both divisible by 6, we get a 4 over 5. Reducing 16 over 20, because they're both divisible by 4, we get a 4 over 5. And reducing 20 and 25, because they're both divisible by 5, I get a 4 over 5. So this one is a yes. Okay, we did get two triangles that are similar by angle. So it's triangle 2 and triangle 3 by side, proportionality. All the sides are proportional. Are these two triangles similar? Find the value of the variable. Well, let's see. Let's remember we've got vertical angles congruent, and let's look at maybe this transversal, so we can say these alternate interior angles are the same, because they already told us that the triangles are similar. And I have parallel lines, so alternate interior angles. So if I swing this one over here, this side 5 goes with the x. So I want to write 5 over x. And this takes a little bit of time, a little bit of practice. You want to make sure you play the match game correctly. And the 3 then goes with the 2. Now, in this particular case, all I have to do is multiply, cross multiply. I get 3x equals 10. Dividing by 3, x equals 10/3. Okay, how about the y? Let's set up for y. The y goes with the 7, so I can go y over 7, the small over the large, and let's see, y over 7, and the 2 goes with the 3. I can use those same two sides. When I cross multiply, I get 2 times 7, which is 14, equals 3 times y. Dividing both sides by 3, y equals 14/3, or 14 over 3. Which is 4 2/3. Okay, let's check this next one. The y minus 3 goes with the 12. So I'm going to go y minus 3 is the same as 12 on the other one. Oh, I'm sorry, that's a 32. And then the 18 goes with the 24. Now, make it easy on yourself. 6 goes into 18 and 24. So this reduces to a 3 over 4. So now it's easier for me to cross multiply. I have 4 times the quantity of y minus 3 equals 3 times 32. Don't forget to distribute that 4, and we get 4y minus 12 equals 96. Add 12 to both sides, and 4y equals 108. Dividing both sides by 4, y equals 27. Okay, can we tell if these triangles are similar? Let's check it out. Let's see, we have an isosceles triangle. It's showing me here that these two sides are congruent, so I have a 9 over here. And the small triangle is isosceles, so we have a 6 over here. So does 9 over 6, comparing two sides of the triangles, does that equal 6 over 4? And I could even check the other two sides but I already know it's 9/6. Let's see, dividing by 3, I get 3/2. Dividing by 2, I get 3/2. Of course, dividing by 3, I get 3/2. So yes, how are they similar? By the angle-angle similarity shortcut. I'm going to switch to red here. Now let's check. We already have angles here, 57 and 92, and those angles add up to 149. So I know that my missing angle here is 31. Do you think these two triangles are similar? No. This triangle over here does not have an angle that measures 57 or 31, so this one is a no. Okay, let's try this last one over here. We have an isosceles triangle with an apex angle of 30, which means the two base angles are congruent. 180 minus 30 equals 150. Divided by 2, and these two angles are 75. 75, 75. Same thing over here on this little triangle. We have an apex angle of 30, which leaves me 150 left over, and the two base angles must be congruent. So yes, the two triangles are similar by angle-angle similarity shortcut. Okay, let's check these two. Triangle ABC, let's see, they have matching angles. So triangle ABC is similar to the smaller version of triangle DEF. Angle B is the same exact measure as angle E. It must be by the third angle theorem. I know that the leftovers are the same. Let's see, X and Y, I'm going to have to figure those out. So I'm going to go 6/16 equals X over the 12, the side it goes with. So 6/16 can be reduced to 3/8, and when I cross multiply, I get 8x equals 36. So X equals 36/8. When I divide by, let's say 4, I get 9/2, which is 4.5. So X equals 4.5, and now to check for Y, I can say, let's see, 8 over the Y equals the 6 over the 16, which I'll reduce to 3/8. So I have 3Y equals 64, dividing by 3, Y equals 64/3. So Y equals, that comes out to be 21 1/3, or 21.3 repeating. AB compares to DE, so I'll fill in the blank there. What side compares to EF? Oh, EF is Y, that compares to BC, and C to A compares with FD. What number goes with the 12? Oh, that would be the X up here. And what number goes with that 8? Well, that's the variable Y. Let's find the height of this tree. The man is 6 feet tall, and he's got a shadow of 2 feet. So height over shadow. We're going to find the height of the tree, so that's our variable. X on top, and the shadow is 24. So height over shadow equals height over shadow. Cross multiply, we get 2x equals 144. Divide both sides by 2, and x equals 72 feet tall.
Will Sophie Zinman please go to the attendance office? Sophie Zinman to the attendance office, please.
Time to work on your assignment.
Did we start any packet on Friday?
Yeah, it's all up there.
Is there lights in that thing?
Is there? Yeah, there's lights on that thing.
Last
LED
Wednesday,
lights.
when I wasn't here, I went took a test. So, do I have to come in like in seminar to take it?
No, you come in during sale. We can't wait till Thursday.
Huh?
Sale. You have to come to sale after school.
Oh,
You can't
okay.
wait till Thursday. You have to take it today.
Okay.
Call home. Tell them you're going to stay in the library. Yeah? Okay. Okay, let me find my movie so I didn't lose it. I have no idea.